So as we already know about work, we have work equals the integral of FDS, right? And so now we will try to find the work done by some common force. For example, the gravitational force, which is mg, and we will have the work equals so this is a vector, and we all know the gravitational force pull you down, so we have a minus here, and this becomes minus mgs, a quite simple integral, and now here. And now if we have a spring, wait, yeah, and we will have it here. And now if we have a spring, then it's a quite familiar integral, and it becomes half of x2 squared minus x2 minus x1 squared, and okay, and this can also be half of x squared k squared if we put this at 0. So as you can see here, this integral you may write this as f s2 minus f s1, where this f is the function uh for the derivative of the force f, and it only depends on s2 and s1, or you can say that it's independent to the path that it has taken. And forces that are true with this, we call them conservative force. So if I have an object moving around like this and come back to where it starts, then you could say that the work done by this equals 0. So to prove this, we have maybe a point 2 here. So the total work equals um, the work from 1 to 2 plus the work from 2 to 1. And as we just said, because the force is conservative, so these two, so um, this can be S1, FS1 minus FS2 plus FS2 minus FS1, and um, equals 0. And so what force is conservative and which one is non-conservative? And so some types of force that you should know that are conservative are, first is um, gravitational force, or uh, electric force caused by a charge, or any electrical field, and also elastic force caused by springs. And some non-conservative force can be, first is friction, or maybe can be drag force. And the difference here is that with conservative force, all the mechanical energy that it creates will be transferred entirely into work. But with non-conservative, some of them might be lost and transferred into maybe internal thermal energy. For example, like friction. Uh, as you already know, friction. If you, for example, like friction, as you already know, it can heat up objects with friction. So um, it shows that its mechanical energy doesn't are not transferred into um, work, but rather also thermal energy. So it's not conservative.